Today, let us solve the problem based on FT curve. So this graph shows force versus time curve of a toy car which is malfunctioning. So it is producing a force as shown in this graph. So from 0 to 5 seconds, the force produced is constant, and then the force is decreasing from 5 to 10 seconds. Then from 10 to 15 seconds, the force is 0, and then it is increasing in negative direction. So here to calculate, see, the first one they are asking what is the velocity of the toy car after 20 seconds if it starts from the rest, and what is the velocity of the toy car after 20 seconds if it starts from 10 meter per second. So to find out final velocity, we need to know momentum. So FT curve, the area covered under FT curve gives the change in momentum of the body. But actually here the force is not constantly varying, or it's not constant. So we have to consider force times time, that is momentum, separately. So first let let us analyze this. So first one is from 0 to 5 seconds, the force covered is the force is 6 Newton. Actually, the force is 6 Newton from this graph. And change in momentum is area under this rectangle. Suppose let us say this is 1. Okay. Now from 5 to 10 seconds, the area covered under the graph is, it is a triangle. Let us say it is 2. Okay. And from 10 to 15 seconds, force is 0. So the change in momentum is also 0 in this. So from 10 to 15 seconds, not from 0 to 15 seconds. From 10 to 15 seconds, force is 0, and the change in momentum is also 0. Now from 15 to 20 seconds, again it is increasing, and you will get the change in momentum as area covered under this. Let us say this is 3. Now to calculate the total force, to calculate the total momentum, we don't want force is varying. So to calculate the total momentum, we can calculate individual momentums from 0 to 5, 5 to 10, and then 10 to 15 and 15 to 20, and then we can find out total momentum. It is sum of all these. So first let us find out the first one. So first one is area of rectangle. This is 1. Okay, equals to, since it is rectangle and from 0 to 5 it is 5, so 6 times 5 equals to 30. This is 1. And second one is area of this one, area of triangle. This is 2. Since there are 2 triangles, I am taking it as 2, equals to half times 5 times 6. So 2 3s, 3 5s are 15. Third one, area of triangle, this is 3, equals to half, from 15 to 20 it is 5 times, this is 10, negative 10. So this is negative 10. So this is equals to 5. This is negative 25. This is 2 and this is 3. So the total change in momentum, total change in momentum equals to delta P equals to area of all these three. That is 1 plus 2 plus 3. So therefore delta P equals to, and why we are taking delta P equals to this? Because delta P equals to f of t. So here delta P equals to area of all the three. Why? Because delta P, the change in momentum, is also equals to force time time. So therefore delta P equals to, let us find out the values. 30 plus 15 minus 25. So this is equal to this 20. And since it is delta P, we have to write units. Kilogram meter per second. This is change in momentum equal to total change in momentum from 0 to 20 seconds is equal to 20 kilogram meter per second. And or we can write other units, Newton second also. Okay, but the question is, A is, what is the velocity of toy car after 20 seconds if it starts from rest? So we have to find out the final velocity after 20 seconds if the car starts from rest. So if the car starts from rest, initial velocity is 0 and momentum is given delta P equals to 20 kilogram meter per second. We already calculated this. So from this we are taking 20 kilogram meter per second. Now to find out the final velocity, delta P equals to m times v final minus v initial. So since v initial is 0, we can write m times v final. Here we can write v initial is 0. Right. Now we have to find out v final. V final equals to delta P by m. M is mass. So delta P value already we calculated. It is 20 and mass is given in the problem 0.756 kilograms. So let us write the same thing, 0.756. This is equals to, if you calculate it, you will get 26.46. Since it is velocity, the units would be meter per second. Now number 2, B. If the car starts from, B is, what is the velocity of the toy car after 20 seconds if it starts from 10 meter per second. That means initial velocity is given as 10 meter per second. Now we have to say change in momentum from 0 to 20 seconds is the same because we calculated it from 0 to 20 seconds. So this is delta P equals to 20 kilogram meter per second. Now let us write the formula, delta P equals to mass into V final minus V initial. So delta P is 20 equals to mass is 0.756 times Vf minus Vi. Okay, or Vf minus Vi equals to 20 by 0.756. Vf equals to 20 by 0.756 plus Vi. So what is VI? Let us substitute the values. So 20 by 0.756, we already calculated this before. So it is 26.46. 26.46 plus V initial is 10. So this is equals to 36.46. Since it is velocity, we can write units as meter per second. So for the first one, it is 26.46, and for the second one, answer is 36.46. So this is the one, this is first one, and this is second one.